Okay, so when you see when you want to find the equation of straight line for form 4, the two-dimensional one, there is x and y only. You need a point, you need 1 point, isn't it? Let's say a is a point 1,4, and then you must have the gradient. So you use y equal to mx plus c, isn't it? You need 1 point and you need the gradient. This is for two-dimensional. So you have x and y only, isn't it? But now our case, we are doing three-dimensional. We have x, y, and then we have another one, z. That's why you cannot use this. So same, you see, when you want to find the equation of straight line AB, okay, where the position vector of A and B are given as this. That means you are given 2 points. A, the position with the vector is this one, that is OA. This is the one like that, meaning. And then B, the position vector is OB, given as B. Therefore, you want to find the equation here, two-dimensional y equal to mx plus c, but here no. You must use x, y, z, then equal to the point. Any point, you can take point A or you can take point B. So you see OA, take point A, OA, plus lambda, then the direction AB. Okay, so now we use direction. We don't use gradient because you cannot find gradient for three-dimensional because we have x, y, z. Or you want to find the equation of the line, you just take x, y, z. So instead of using point A, now you can also use point B. Just like form 4, I give you 2 points here. You have the M. So let's say this point is A, 1, 4. B is, let's say, is 5, 7. So you can either use this point or use this point to find the equation. Isn't it? Any one. So it's the same. Just the way of writing is not this. It's like this. Okay, remember. Okay, now I give you example. So you see, now example 5. Find the vector equation and Cartesian equation of each of the following straight line. So now I'm going to explain to you what is vector equation and what is Cartesian equation. Okay. Now, L1, line 1, passes through the point. Now you see they give you the point and parallel to the vector. Parallel to the vector. When we talk about parallel, means same direction. That means this is the direction. Okay. This is the point. This is the direction. So you are given the point, you are given the direction. Just like form 4, you are given the point, you are given the gradient. But here we don't use gradient, we use direction. Okay, so how are we going to find the equation of this line? You see, I show you. Okay, here, look at here. Okay, this line passes through the point. Okay, the point, this is the coordinate, we write into position vector. Okay, and then parallel to this. So that means the direction is negative 160. This is the direction. Okay, okay, this P don't, okay, so there is a direction. So when you want to write down the equation of the line, then equation of the line will be follow this. Okay, follow just now the rules here. Okay, so it's x, y, z. Okay, this is x, y, z, short form for x, y, z. You just put the r. So x, y, z is you take the point A and then plus lambda or whatever, you can put t and then the direction. So point plus t direction. So remember, this is point. This is P-O-I-N-T, point. Point plus t direction. This is the direction must have t, the point cannot. Okay, so therefore you get this, or you can write like this, or you can write like this. It's up to you. Okay, so you write like this. So when you write like this, r, actually this is x, y, z, xi plus this r is xi plus yj plus k zk, like that. So it's this one, 2i minus 5j, 0z plus t, and then all this. So this is called a vector equation. So this is called a vector equation. This is called a vector equation. Okay, so and then you look at this again. X, y, z is this one plus t, this one. So that means we can equate them. X equal to 2 minus t. Then your y equal to negative 5 plus 6t. Your z equal to 0 plus 0t. So from here you get t is equal to this one. T is equal to this one. P is called a parameter. Do you still remember? Then x, y, z is our variable here. So we remove the parameter. Then we have this 2 minus x equal to y plus 6 over, sorry, y plus 5 over 6. Okay, so this is called a Cartesian equation. But one thing I remember this actually, okay, then you can write like this lah. You just multiply the 6 over here, you get 12 minus, okay, this one you know. So this is called a Cartesian equation. Okay, actually this is two-dimensional also because here the z is 0 lah. Okay, later we go to another example where all these are not 0. Actually here the Cartesian equation you make it a habit lah. So y plus 5 over 6 okay, look at this one. Actually this one you write it like this, negative x minus 2. Why? You remember every time Cartesian equation, of course it's not compulsory, but it's good every time you remember y like that. This is positive y and positive x. So you can write it like this. This is x minus 2 over negative 1 equal to y plus 5 over 6. Okay? Remember. So every time you remember, this is x, this is y. Okay, why I want you to do like this? This is because, you see, if you write like this, that means you know this straight line passes through the point 2. The point is 2, negative 5. You see, correct or not? You look back, you can see. Is it 2, negative 5? 0. Here we don't have z, that means it's z minus 0 over 0 lah, tak ada lah. Okay, that's why you see they passes through the point. You see they passes through the point 2, negative 5, 0. Is it? Okay, and then that's why I want you to write like this. And then what is this, the bottom one? The bottom one is the direction. You see the direction is negative 160, negative 160. So from the Cartesian equation, you can see the point and also the equation. The direction. Okay, you see I show you another one. Example 5. Okay, B. L2 passes through the point with position vector. Now you are given the point. Okay, I show you. Of course, later you don't have to draw this diagram. You don't have to draw the diagram. I just remind you. So this is the point and parallel to the vector. Parallel mean, when we talk about parallel mean, in two-dimensional is same gradient. But here is same direction. We don't use gradient. Instead of gradient for form 4, now we use direction. So parallel to this vector means parallel to this is the direction. So this is the point. Okay. So now you want to find the equation of the straight line, the equation of this straight line. What you have to do is r and then point plus lambda direction. Of course, this one you want to put whatever lambda, you want to pick t or you want to put k, it's up to you. This is a variable. So it's a point plus direction. So the point you just substitute negative 2, 1, negative 3, and then the direction is this one. Here I put lambda. So this is called a vector equation. So this is a vector equation. Okay. So you see, this is a vector equation. Vector equation. Or you can write like this. Of course, the r here means what? X, Y, Z. This is X, Y, Z. So negative 2 plus j minus 3i lambda, all this. This one also same. Either one, you write either one. Okay. If the question give you like this, you write like this. If the question give you in this form, you write like this. Okay. So this is called a vector equation. Okay. Now I'm going to find the what we call the Cartesian equation. So here I write like this, x, y, z. Okay. So negative 2, 1, look at here. I just change this one back into x, y, z. So I just equate them. X, y, z equal to this. Okay, negative 2 plus lambda, 1 plus 2 lambda, and negative 3 minus lambda. Then after that, I write out the equation. X equal to this one, y equal to this one, z equal to this one. So, okay. After that, I just find this is lambda equal to x plus 2. So here, this one, x very good. Positive, no need to change. This one, the y also very good, don't need to change. But here the z is negative, the other one. We want the z to be 1, remember that. So what we must do? Okay, this is very good, this is very good, but this is no good, okay? Because negative, I want to make it into positive. That is how I do it. X plus 2, okay? I take out the negative. Okay, so this one is x, this one is y, this one is z. You see, so good. And then after that, you see x plus 2 over 1. here. Okay, x plus 2 over 1, y minus 1 over 2, and then here is z plus 3 over negative 1. Okay, then this is a Cartesian equation. You always remember, you write like this better. Y, okay, now I show you. From here, you can see from this Cartesian equation, if this one is x, this one is y, this one is z. Remember, you cannot have 2x, you cannot have 3y or whatever. Only x, positive y, and positive 1z. Then that means this line will passes through the point negative 2, 1 passes through the point, and then negative 3. And then the direction parallel to the direction is 1, 2, negative 1. This is the direction. This is the point that the line passes through. You see, correct or not? You check and see whether it's correct or not. You see, given negative 2, 1, negative 3, the direction is 1, 2, negative 1. There you see, same or not? It's exactly the same. Okay, so this is for B. Okay, now we go to the last one, example 5C. Here, you see, you are given line 3 that passes through the 2 points. Okay, form 4, how are we going to solve this? Let's say you have an equation. You want to find the equation where you have 2 points. This point, let's say, is A, 3, 1. And then point B, let's say this is 5. Okay, and then let's say this is 5. So how are you going to find the equation? You find the gradient, y2 minus y1 over x2 minus x1. So your m will be this one minus this one, this one minus this one is 2, isn't it? So the gradient is 2. Then you can find the equation. You just take the point x, y, then you can get the equation. So take any point. Okay, let's say I take this point with this point, form 4. So I have y minus 1 over x minus 3 equal to gradient, y minus 1 x minus 3 equal to 2. So y minus 1 equal to 2x minus 6, y equals to 2x minus 5. Or you can use y equal to mx plus c, also same. Okay, this one you can do it yourself. Okay, now I come back to our problem. Now here they say they passes through the point 3, 1, 4. Okay, position vector A, position vector B. Okay, and then here I want to find the equation. So let's say here you have so many points here, millions of points here. I choose one point here to be P, and then the factor equation is this one. So here I have 2 points to choose. This is point, this is 1 point, this is another 1 point. I have 2 points to choose. And then now I must find the direction. So I must find this direction. Just like just now, I have to find the gradient. But here I cannot find the gradient. I find the direction AB. So I find this one AB. This is the direction. The direction is not given, so you have to find. So I find the direction. So this is the direction I find. AB is OB minus OA. So I take OB minus OA. I get this. So this will be the direction. And then points, I have 2. So you want to find the equation of the equation of the line, you must have point, this is point, lambda, and then this is the direction. Is it? Point plus lambda, direction. That's why I substitute. When point, I can take any point. I have 2 to choose. Just like form 4, I have 2 points, you can choose any 1 point. Here also same thing, you can choose any one. You can choose any one. So let's say I choose this one. I have 3, 1, 4, and then lambda, and then the direction. Not B, is the direction AB. This is the direction. Okay, so I put in the direction. So after that, I will get this answer. And then I want to get the Cartesian equation. So I just put x equal to 3. Now look at here, x equal to 3 minus 4 lambda, then y equal to 1 plus lambda, z equal to 4 plus lambda. So from here I get the lambda. Remember, the x always positive, the y always positive, the z always positive. So this is the one. So from here I can see that the line passes through the point. The line passes, this is the line passes through the point 3, 1, 4. 3, 1, 4. And then the direction is negative 4, 1, 1. You see, correct or not? is the direction is negative 4, 1, 1. Of course, you want to find the equation of the line 3. If you don't want to use point A, you can use point B also. Same. Okay, you will get the same thing. Okay, all accepted. Okay, if you use B as the point, then the equation should be something